You are welcome to this class, and in this class we are going to continue with the current division rule. So this class is going to be the part 2 of the current division rule. Try and watch that of part 1 so that you'll be able to understand the one in the part 2. In part 1, we realize that we can apply current division rule when we know two things in parallel and we know the total current coming to it. And per the current division rule, we got to know that the current here, say I1. If I want to know I1, the total current is coming, and I want to know I1 is the other resistor over the sum of the two resistors times the total current. And this is how current is shared among two resistors in parallel. Note that the current division rule can only be used when you have only two things in parallel and you know the total current coming to them. So now, let's continue with a second example. Let's say, for instance, in this question, let's say I want to know the current passing through this IA. Now, for me to know the current passing through this IA, this same question also, I can also apply the Kirchhoff's current law to be able to find IA. But if I go through the Kirchhoff current law, it's going to lead me to about 3 simultaneous equations before I'll be able to come up with IA. But then, if I can easily see some things in parallel, some things in series that can let me break down this to know the total current, then I can easily get to know that I have to use the current division rule to easily get to know what IA is. And how am I going to go about that? First of all, I have to get two things in parallel, and then I get to know the total current. Now, let's find the total current first, IT. It's going to be the voltage over the total resistance. Now, how do I find the total resistance? If you watch the series and parallel video, you realize that 3 and 6 are in parallel. So I do 3 times 6 over 3 plus 6, and I get 2 ohm. Now, if you have watched that video very well, you realize that this 2 ohm is going to now be in series with this 8, right? So it's going to be 2 plus 8, and it's going to give me 10 ohms. Now, one interesting thing is that after getting 10 ohm, you're realizing that it's going to be in parallel with this 10. Now, though we are able to use our eye to see this and this are in parallel in series, one thing is that if you are applying the current division rule to solve a problem, you always make sure that anytime you have two things in parallel, you redraw the circuit because it may be of need. So now I have gotten to this point where I know here is 4, this is 10 ohms, and I'll put all these resistors together, and I've gotten to know that here also is 10 ohms. And here is 4, and here is 18 volts. And find the total resistance. But as I've gotten to this, let me redraw because I have two things in parallel, which may be of need to me when I'm applying the current division rule. Now, let's continue finding the total resistance, and I'll explain why I redrew this because it may be of need. Now, we can see that 10 and 10 are in parallel, so that's going to be 10 times 10 over 10 plus 10, and that's going to give me 5 ohms. Now, the 5 ohm afterwards is going to be in series with this 4, so I'm going to get the total resistance to be 4 plus 5, which is now going to be 9 ohms. So I now know that the total current is going to be 18, which is the voltage, divided by the total resistance, which is 2 amps. It means that the current coming here is 2 amps. So what it means that when this 2 amp gets to this junction, the 2 amp is now going to divide. So here is 2 amp, and it's going to divide among this and this. One interesting thing is that this 2 amp, when it gets here, how much will come here and how much will come there? And that is when the current division rule becomes important. Let me use this. Now, this 2 amp has gotten here. How much will come here and how much come here? Intuitively, because this is 10 ohm and this is 10 ohm, we know that then they will share these 2 amp equally. But ideally, I want to find the current in this 10 ohm. Now, the reason why I want to find the current in this 10 ohm and not in this 10 ohm is that because this IA that I want to find is within this 10 ohm, because I put this 3 and this 6 together, and the IA is within there, right? And then after that, I put this before I got this 10. So I'm interested in finding the current here and not the one here. So how do I know the current here? I'm going to use current division rule. I is going to give me the other resistor, which is 10, divided by the sum of the two, 10 plus 10, times the total current, which is 2 amp. And we all know definitely is going to give me 1 amp because we are two resistors, we share the same. So the current coming to the 10 now is 1 amp. Now, the reason why I made you redraw this circuit is that it helped you realize that I was able to apply current division rule because I had only two things in parallel and I knew the total current coming to them. Now, this 1 amp is the current in this 10 ohms. This 1 amp is the current in this 10 ohm. But don't forget that this 10 ohm came from 3 and 6 and 8 together. It means that I can come back to this circuit and say that here is 1 amp. Because this 1 amp is going to the 8, 6, and 3, which is together is 6, is 10. Now, this 1 amp now is coming and it will get to this junction. So we want to know how much will come here, which is IA. And we know that because 3 and 6 are in parallel, and I know the total current IA, then I can apply the current division rule to get to know IA. So what will be IA? IA will be the other resistor, which is 3, over the sum of 3 and 6 times the total current. I'm going to get 309, and IA is going to be 1 over 3. So basically, I've been able to, with some few steps, by finding the total resistance and sharing the current bit by bit, I'm able to find IA without applying the Kirchhoff's law. Let's use another example so that you can get this thing intuitively well. Let's see an example like this. Let's say that I'm interested in finding, let's say, the current here. Let's say IX. Now I want to know IX. And I can easily apply the concept of the current division rule and not Kirchhoff, because Kirchhoff will lead me to a lot of work. Because you see, I can easily see that I can easily find the total resistance. And you see, anytime you can easily find the total resistance within the circuit by just doing series parallel, then you know that the possibility of using the current division rule is there. Now you see, if I had a circuit like this, applying the current division rule becomes impossible. 10 volts, 12 volts. Now, by watching the series and parallel video, you can all see that 2 and 4 are not in parallel because when I go around, I meet an element. 3 and 2 are not in parallel. 3 and then this 4 are also not in parallel. So because I'm not able to identify any parallel within this particular circuit, then it will be impossible for me to apply the current division rule in that circuit. So in this circuit, if I want to know the current within the circuit, then I may apply the Kirchhoff's laws to do it because it's impossible to apply the current division rule principle because I can't see things in parallel. But this problem that I have now, I can see that this and this are in parallel, is going to be in series with this, and I'll be able to know the total resistance easily. So because of that, the possibility of using the current division rule is there. So let me use that idea to find Ix. So we can see that 12 and 4 are in parallel. So 12 times 4 over 12 plus 4, and this is going to give me 3 ohms. Now the 3 ohms is going to be in series with the 7, so 3 plus 7 is going to give me 10 ohm. Now, the 10 is going to be in parallel with this. And as I said, as soon as you are working with current division rule and you get to know two things that are going to be in parallel, redraw the circuit down because you may need it. You may need it in the process. So we just got this one to be 10 ohm, and here is 2 ohm, here is 1 ohm, 32 volt. I'll redraw this down because I'll have two things in parallel. For that I redraw. But now let's continue finding the total resistance. The total resistance, we are still finding the total resistance. So we can see that this 10 and these 2 are now in parallel. 10 times 2 over 10 plus 2. and that's going to give me 20 on 12, and that's going to be 4 here, 5, 4 here, 3, 5 on 3. So the total resistance RT is going to, this and this has given me 5 on 3, and it's going to be a series with 1. So 5 on 3. If you don't understand this parallel series I'm doing, try and watch the series and parallel video from part 1 to part 3, and you easily get it. So now this total resistance now is going to give me 8 on 3. 8 on 3. Now, this is the total resistance. So if I want to know the total current, then IT is going to be 32 divided by 8 on 3, and that is going to give me 12 amps, right? 12 amps. So we know that the 12 amp is the total current coming here. Realize that, have you seen that this circuit has become needed? Because now I want to find the current that will come to this 10. Not forgetting that the current coming to, I'm interested in finding the current in this 10 because the Ix I want to find is within this 10. Now, by the current division rule principle, how do I know the current in this 10? I'm going to say, let me write down here. So it's going to be 2 over 2 plus 10 times the 12. And this is going to give me 2 amps. What it means is that the current coming to this 10 is going to be 2 amps. So I'm bringing this within the circuit that the current coming to this 10 is 2 amps. So I'm coming back to this main question because this 10 ohm is 12 and 4 and 7 together. So it means that the 2 amp actually I can also show it to be here because it's passing through the 7, 4 and the 12 together. Now that I know the current here to be 2 amp, then I can easily share it among 12 and 4 to find Ix. So what will be Ix? Ix will be the other resistor 4 over 4 plus 12 times 2 amp. And this is going to give us 8 on 16. That's going to be 1 on 4 amp. So have you seen that easily we've been able to find the current Ix just by applying the current. Have you seen the current division rule is very interesting. Now, let's see another example. Let's say I have this simple example and I'm interested in finding the current here, IB. Now, what do you think IB is going to be? Have you noticed that this 3 and this 2 are in parallel? So if I can know the total current coming to them, I can easily apply the current division rule to know IB without solving the circuit with Kirchhoff or any other principle. So now let's find the total current, IT. How do I find IT? IT is going to be 3 and 2 in parallel, right? I'm going to find the total resistance. 3 and 2 are in parallel. After it's going to be in series with 4. So 2 times 3 over 2 plus 3, that was 6 on 5. And 6 on 5 is going to be in series with 4. And that is going to be 26 on 5. So this is the total resistance, 26 on 5. So now what's going to be the total current? It's going to be 26 divided by 26 on 5, and that's going to be 5 amps. So we have the total current now as 5 amps. What it means is that the total current here is 5 amps. Why is it going to share among 3 and 2, which are in parallel? So now IB is the current in the 3. So we're going to use the other resistor, which is 2 over 2 plus 3 times the 5 amp. And I'm going to get 2 amps. I mean the current IB is going to be 2 amps. Simply, I found IB by applying the current division rule. How did I know I can apply the current division rule? I saw that this and this are in parallel, in series with this. I can easily know the total resistance without trying to do delta star and all those kind of transformations. So far I can do parallel series, try to break down to get total current. I means I can break the system down simply and I'll be able to get things in parallel and things in series. Now, lastly, Let's look at this question and it will explain the concept of current division rule well for you. Now we can see that here, what will be the total current here? The total current is going to be the total current is going to be IT. IT here is going to be, first let's find the total resistance, 4 and 12 in parallel. 4 times 12 over 4 plus 12, I get 3, and 3 and 6 are going to be in parallel. Now you realize I'm going to have two things in parallel now. This is 6, this is 3, and I'm going to need it, so I put that down. Now this 3 is going to be in parallel with 6. 3 times 6 over 3 plus 6, that is 2 ohms. So the total current is going to be 36 on 2, which is going to be 18 amps. So this actually is 18 amps. 18 amps. Now that I know this total current 18 amps, I'm going to share between 6 and 3. Now one thing I wanted you to see is that this 18 amps here, have you seen that 6 and 12 are in parallel? But this 18 amp, you know that it's going to be shared among here and here. And the one that is coming here is going to the 4 and 12 at the same time. So though this 6 and this 12 are in parallel, I can't just apply the current division rule unless I break it down to only two things. So it has to be only two things in parallel and you know the total current. So I'm going to apply that concept here to find the current coming. So let's say this question, we actually want to know the current in this 6 Ix. So here, I'm not going to do, after getting to know the 18, I'm not going to use 6 and 12 to know Ix. No, I have to put 4 and 12 together to get 3 before I'll be able to find Ix. I have to get only two things in parallel. So how do I get Ix now? So Ix is going to be 3 over 3 plus 6 times 18 amp, and that's going to give me 6 amps. So simply, we are done with the concept of current division rule. I know this question makes us understand very well that two things in parallel, and I should know the total current coming to them. So it's not just things in parallel, only two things in parallel and the total current. So thank you very much. Watch all the other examples and you'll be able to understand this fully. Thank you.